Now let's discuss 4.2 linear regression. First of all, see that the meaning of uh, regression analysis. What is regression analysis? Regression analysis is a set of statistical process for estimating the relationship between a response variable and one or more explanatory variables. So this is regression analysis. Now, when it's come to the linear regression, it's going to be only one explanatory variable. So we will call this is a simple regression as well. Then is a statistical process for estimating the relationship between response variable and one. So then I can delete this one, I can erase this one, and I can bring to like this one explanatory variable. So this is simple regression, and the other regression is polynomial regression if there is more explanatory variables. So in a linear regression, uh, we fix the line of this is few data points. I will take only 3 at present, and okay, one more. So those, so we can see that there is a relationship, linear relationship, and so we are going to represent these points by a line. Then we are going to find what is the best line. So we may have best different options like this. So likewise, what is the best line we can fix to represent those points. So the technique we are using, assume that this is the line, and I will take this point is 4 6 point. This value is 4, and the relevant this point going to represent from here in this point. What is the coordinate of this one? 4. I will take y1, and I will take this distance as d1 from here to here, and then this one I will take 6 6 8. So this is 6 8 point, and we are going to represent this point from here. It means this is going to be 6y2, and the other point, this one, this is going to be 8 4 again, and we are going to represent this point in this place. In that case, this is going to be x value is still 8, this is y3, and I will stay with those 3 points at present. Now this distance I will take d2, and this distance I will take d3. Now d1, how do we find the d1? Y1, we know that when we have a 2 point, x1 y1 x2 y2, we know how to find the distance. The distance is y1 minus y2 square plus x1 minus x2 square. So likewise, when I calculate d1 distance, it is going to be y1 minus Okay, 6 minus y is, okay, I will write, yeah, y1 minus 6 square, y1 minus 6 plus 4 minus 4. You can write 6 minus y also, but I write y minus 6, still the same, because we are going to get the square root. So 4 minus 4 is 0. This is y minus 6. Okay, I will stay with the squares. So likewise, d2 square, when you find, you can get, the x is going to be cancelled out, y2 minus 8 square. And d3 square, you can see that y3 minus 4 square. Then let me take, this is d square equal d1 square plus d2 square plus d3 square. And what we are doing, we are minimizing this distance. So this d1 square is, we call, sums of squares. So sums of those squares, addition, sums of squares. So we are adjusting these d1 and d12, and we are getting the minimum d. So minimum d. Or you can tell that summation of di. So I equal 1 to 3. Summation di, uh, minimum of summation di. Or if you represent addition is value, the minimum value. So you can find by differentiation and other techniques, we can use to find the minimum value. The computer does this. So computer is adjusting these values, this line, and you will get the least squares. So when you get the least square, this value is become minimum. And at that time, when d is at his minimum, then we call this line is line of best fit. Line of best fit, or least squares, because squares is less. Least squares, regression line. So there is a correlation. Correlation is linear, so we have to draw we are going to represent by a line. Then what is the best fit line? The best one is, we are fixing by adjusting these distance squares. We are getting the minimum distance, addition of minimum distance squares. And finally, this is still just a line. So this is, let's say y equal mx plus c, or we'll say that y equal bx plus a. So b is the gradient. So b is the gradient, and a is the y intercept. So b represent the change in y. If I take, this is x and y. So change in y for each unit change in x. And let's discuss example 3. So we have the this is wind speed and gust. So we have this kind of dot. So basically it is a linear relationship. Question number A. Describe the correlation between daily mean wind step and daily maximum gust. So this is W and G. W and G. Now we can see that there's a strong positive correlation. Uh, there is a strong positive strong strong positive correlation between wind spread and the guest. The strong. Why I am using this strong word? Because if one variable increasing by 1 unit and the other variable also increasing by 1 unit, then it is a one-to-one. If one independent variable is increasing by 1 unit, so the dependent also increasing by 1 unit. It's a perfect correlation, one-to-one correlation. So it is a strong correlation. It means the line should be 45 degrees. In terms of tan 45 is 1. So tan value has to be in other way, tan theta equal 1 or theta equal 45. So it has a strong correlation. So when you look at it, I can see that so it is nearly 1-to-1, or maybe a small change is there. So we can tell that this is a strong correlation. It means for one unit of variable, the other one is moving 1 unit to variable if it is 45 degrees line. Question number 2, part B. Give an interpretation of value of gradient of this regression line. So the regression line is given by G equal 7.23 and 1.82 W. I'll put like this, I'll arrange like this: 1.82 W plus 7.23. This is y equal mx plus c form. Now you can see the gradient. The gradient is 1.82. M, or usually we work with y equal b um, x plus a. Then let me stay with this one. Y equal b x plus c plus a. So b value. So b is 1.2. This is the gradient. So what is the meaning of gradient? This is 1.2, 1.82 over 1. It means, so this is wind speed, this is wind speed, and this is gust. So one unit of wind speed, the 1.82 unit of 1 unit of wind speed causes to increase the 1 unit of gust speed, 1.82. So in other way I can write W to G. The ratio is 1 to W is 1 to 1.82. The wind speed increases by 1 unit, so we'll write if wind speed increases by 1 unit, the gust the gust increases by 1.82 units. Or you can tell that if winds increase by 10 units, so this is 1.82, yeah, ratio 1 to 1.82, W to G, 1 to 1.82. If it is 1 to 1, if it is 10, it is going to be 18.2, or roughly you can tell approximately uh, 18 knots. You can tell 1 unit increase, or you can tell in terms of 10 units. If wind speed increases by 1 unit, the gust increases by 1.8 units. If it is 10 units, it is 18 units approximately. Part C, justify the use of linear regression line in this instance. According to the correlation, uh, that there is a linear relationship between correlation. There is a linear relationship between G, and W, and linear regression line is a suitable model. Instead of correlation, I will change according to the scatter graph. There is a linear relation between G and W. Hence, statistical. Now, important thing about this linear regression line is the prediction. We can predict the data. If we predict the data in between the given range, then we will call it as a interpolation. If we predict the data outside the range, for example, assume this is the minimum value and this is the maximum value of the independent value, and more beyond this range, so this is the area or this is the area. If you try to predict out of range, then this is we refer as the extrapolation. If I refer the data set, I can see that W and G, I can see the minimum value is, if I'm not wrong, minimum value is 7, and the maximum value is going to be 18. Now this is 7 and this is 18. If you try to predict or any value, any uh, response variable value in between this range. So for example, I want to find 7.112. Then I can use that the equation and I can calculate that response value. So this calculation is carried out in between 7 and 18 or within the actual range, the given range. So then it is we call usually uh, interpolation. But if I ask, okay, calculate 6.5 or 19 or 18.11, so those values are, those win values are in this area out of range. So then we call that kind of prediction extrapolation. The technique we are going to use interpolation, and that kind of prediction out of range, it is called extrapolation. Usually these extrapolation values are not reliable, so it is going further and further. So assume this is, we are expecting like this, the curve is going, then W, let's say around 60, we will get this kind of response value. They are not reliable values. The values are reliable within the actual range. The minimum value is 7 and the maximum value is 18. And it is important that we only doing interpolation with the uh, regression line. We don't do extrapolation unless instructed. Interpolation, the prediction for values of the dependent variable that are within the range of the given data. So they are not possible on this side. Now we'll discuss example number 4. As a table, and there is x independent and a dependent value. I can see minimum is 33, so minimum is 33 to maximum is going to be 40. Now there's a scatter graph as well, and the equation is y equal 0.624 x plus 8.91. The coefficient x coefficient is 0.624. The regression equation used to estimate the head of circumference of baby born 39 weeks and the born 30 weeks. Comment on the reliability of these estimates. So from this graph, 30 and 39, when you look at the minimum and the maximum, uh, 39 is within the range, within, this is out. So then the reliability of the prediction, this prediction is more reliable because 39 is within the range, but 30 is out of the range. That prediction is not reliable. Also we can talk about the reliability, the sample size, and the randomness of the sample. Other two things we can discuss of the reliability. Yes. Question A, the answer you can see that the prediction for 39 weeks is within the range of the data, so it's so more likely to be accurate. 30 is the out of range, so it is not as reliable. And part B, explain the regression equation given above is not suitable for this estimate because in this sum, part B above, I can see a nurse want to estimate the gestation period for a baby born with a head circumference of 31.6. It means now according to this graph, so mm, this is head circumference and G period. So this is X value independent and this is Y value. So the nurse is trying to predict on independent value using dependent variable, which is not appropriate for the regression line. So regression line we use to estimate the range of the dependent value. Using dependent value we estimate the using independent value we estimate dependent value, not vice versa. Using dependent value to independent. If you want to do this one, then we have to change the axis and draw the scatter plot and then fix a line, regression line, and then we have to predict. So in that case, this is going to be the gestation period and this is going to be the head of circumference. Now y here, x here, yes. Now I can predict because I bring that one as a independent variable. So the message is don't try to evaluate independent variable by inserting a dependent variable. It is not acceptable for regression lines. It is only allowed to submit dependent value and predict submit independent value and get the dependent value. Let's discuss exercise 4b.